All right, Jianglian, please. So this work is a little bit relevant to the work of Yufan and you on how to improve the machine translation problems. For now, we're working on the code comment generation problem. So it is basically a machine translation problem to translate the source code into the comment. And here it seems that they have some isotopic replacement. Seems quite relevant. By the way, Yufan, have you read this paper by yourself?
No, actually no.
Okay, so it's better you prepare. It's better that you can check these papers by yourself, so that you can ask more constructive and insightful questions in this session.
Okay. Next time I will read this way related to me.
Yeah, sure. So the title of the paper is called Improving Machine Translation System via Isotopic Replacement. Very straightforward. And here is the authors list. So the main author is PhD in Peking University, together with some corresponding authors and their mentors also in Peking. Any question?
UCL, I think Jie Zhang is actually a lecturer in King's College, right? He is not in UCL anymore.
Oh, okay. I got this in the paper. Maybe it's outdated.
And the assistant professor, I think he is a research fellow, but no, doesn't matter. Okay.
Okay. So the model used in this paper is called.
Oh, by the way, so FSC will be held in the middle of November this year. I suggest we attend the conference as much as possible. And also I shared the accepted papers last night. If you look into the details, we find that a huge number of researchers have invested their time and energy on the code analysis, deep learning-based code analysis, for example, the code generation, review generation, code comment generation. So this area kind of clouded. So we need to speed up the progress. And also we need to, especially Yufan, I suggest that you personally, you attend in-person conference. So you can ask questions, don't be shy, and try to find the relevant. Yes, in Utah, it will be held in Utah. So my suggestion is that you go there, ask questions, and if you find some people are attending the meetings, I think I'm not sure the first and the second authors will attend the conference. But if they are, it's better for you to have discussion with them.
Okay, thank you.
Okay, so actually the model used in this paper is called context-aware replacement for improving machine translation, and it's called CAT. Before talking to the CAT, I want to introduce the model trans-repair, because CAT is highly based on the trans-repair, and trans-repair is also the model proposed by the same set of authors. So the first figure is examples. And they are saying that there are many fairness issues in the machine translation examples. For example, when using Google Translate from English to Chinese, when you are saying mail do good research, and when you translate to Chinese, here the corresponding word is also from in Chinese is 很好的, and in English is meaning very good. However, if you just change one word in the original sentence from man to woman, then this good is only translated to a lot. So there is this kind of fairness issues as they observed, and they want to address.
This is work about trans-repair for the fairness problem.
Yes. Yeah, because CAT is highly based on that, and they share many same subcomponents. So it's better to explain the trans-repair first. And they are saying the existing work has tested whether machine translation system provides stable translation for semantically equal transformations, such as the synonym replacement. But they are saying no previous work has focused on the testing and repairing of the translation result. And this kind of inconsistency should be repaired by some context similar transformation. So that's what they are trying to address. So they are saying that there are sometimes the simple gender-based transformations from boys to girls will cause issues, and they are solving this.
Hi, Jianglian. So, just out of curiosity, I'm wondering why does this problem exist in the first place? Is it because when they train the model, the text they use only describe about men and males? Because if the data itself is neutral, I can't think of why this will happen in the first place.
I can't get the details of Google Translator, so can't give precise answer, but I feel almost the same because they may have different data sets for men and women, and that causes this kind of bias.
Okay, I see. Yeah, thank you.
Comments here is called a fairness. It's called a fairness issue. For example, if we want to decide the candidates for some positions, usually some positions will usually have men candidates instead of women candidates, which means that if we collect the training data, the number of training data is about men is much larger than that of the women, which means that if the model makes some recommendations based on the frequency, men have a large likelihood to be recommended. So this is generally caused by, I think it's just caused by some historical phenomena. And so the researchers, especially for the AI researchers, invest a lot of time to fix this fairness problem.
Yeah, I think so. Okay, thanks, Dr. Lin and.
Okay, let's move on.
So for trans repair, they have 3 phases. The first part is called automatic text input generation. So for each sentence, trans repair will conduct sentence mutations via context similar word replacement. For example, for an input male, they will find similar mutants like female or boy or girl. And then the mutant candidates are filtered using a grammar check. And if after you replace the word with other mutants, if the whole sentence doesn't pass the grammar check, you just discard it and you only keep those that pass the grammar check. And that's basically the idea from here. And there's a detailed process here. So for mutants, the model, they use 2 different types of models, the GLOB and the SPICI. And these models give the word vector for each word, and they basically do the simple cosine similarity between the words. And if it's higher than a threshold, you consider them paired mutants. And then for the mutants, you replace that and form a new sentence. You do the word replacement and form a new sentence. And they also did extra structural filtering. So for example, one and another are context similar words, but a good one is a good phrase, but a good another is not. So they just use a Stanford parser to parse each mutative sentence. And if it doesn't follow the same structure, then you discard it.
So here, one and another will have a large cosine similarity based on their examples, right?
Yes.
All right.
And the second phase is called automatic text oracle generation. So basically, you want to identify the any translation issues, and you want to identify the inconsistency of their translation result. So you kind of want to get the similarity between the translated result of original sentence and the translated result of the mutated sentence. And we go through this algorithm, and your TS is the translation of the original sentence, and TS prime is a translation of the mutant. And they use these two, GNU, WD, to get different slices between 2 sentences. For example, there are 2 sentences, and you get the word diff, and AD represents the first sentence, and B and GH represents the second sentence. And then they delete the slides from the translations one at a time. For example, if your original sentence is A, B, C, D, E, F, and then—
Sorry, I didn't get a point. So a minor suggestion that when you get in a slice, so it's better to control the number of words for each slice, maybe within 30 words. So just a few bullets. So you're actually talking about the pseudocode, right? So if it is pseudocode, you would better to using some animation instead of go through those texture words. So which will be more intuitive and easier for the readers and audience to follow. So here the question is A and D and B and G and H. And what does slice means? The slice, and there's correspondence between the slice.
One slice is, for example, one of this A, or one is this B, or one is this GH. And
each token is a word. And the Y, G, and H will be considered one slice. And what's the relevance? Why one word for one slice, and sometimes the two words for a slide?
Because it considers the common parts of these two sentences, and BC and F.
So which more like the difference between two sequences, right?
Yes.
I got it. So, and also the difference will have the alignment.
Yes.
All right.
Basically, for each sentence, you split them into different slices, and then every time you remove one slice and put that into a bigger set. So for this A, B, C, D, E, F, it will have two subsequences. For example, you delete A, that's a subsequence, or you delete D, that's a subsequence, and then you put it into a bigger set, T.
I didn't get it. So what do you mean by put into a bigger set T?
Yeah, for example, every time you delete a sub slice and you put it into a big set, TO.
And the slice only for the difference part and also for the common part?
Only the difference part. Because they want to, I think they want to reduce the influence by the, they only want to evaluate the different part.
So I think this algorithm is better to use in animation. That would be much more helpful than those pure words.
Okay. And then you have two big sets, right? One for each sentence. Then it have internal similarities between all the elements. So you could imagine the complexity is like n times m, because you get one sentence from the left.
So the TO and the TM only contain the slice from respective sequence, right?
It contains what you have after you delete the slice.
So we can only delete the difference.
Yes.
So basically the TO, so for given an example, for TO, it will only consider A and D. And for TM, it will only contains B and GH.
No, TO contains BCDF and ABCF, the two subsequence.
Okay, so it contains the subsequence part. Okay, more like the complement part.
Yes.
Okay, the number will be just the difference, right? So there's since there's a difference, it will be 2 times 2 will be 4, right? The combination.
Yes.
All right.
And then they compute the similarity scores, and among all of them, they just use the highest similarity scores. And if that similarity is smaller than a threshold, it will saying this translation is having inconsistency.
You're talking about the procedure, and then what is the rationale?
After you report the inconsistency, you will try to repair the translation.
So here it's trying to provide a partial sentence, right? So by removing one slide for each time, we will have a partial sentences. And why do this? Why this way?
Is it because the fairness is induced by a certain word, and then if you remove that word, the similarity should be small, right? Because here we should find some word that cause the unfairness. So,
so here, for example, so Jianglian provide a very lengthy slice here. So let's put it simple. Suppose A is a boy, B is a girl, right? Because they will have a correspondence. And D corresponding to men and GH correspond to ladies and women, something like that. And how does that make a difference? And what's supposed to be a difference? So this is still a test generation to identify the fairness issue, right?
Actually, the A and B are not boy and girl. A and B are this sentence, and you extract the different.
All right, you're right. So the part remove N and B.
Yeah, so A and B are, for example.
Yeah, I'm talking about the A is boy. So by removing the boy, but given one sentence removing boy and given another sentence removing girl. So if there's similarity, so the goal, and so I'm just trying to strengthen that the goal here. So when you're talking about the framework, you're talking about the procedure and provide all the details. But up until now, at least for me, I still losing the rationale and what is the goal here. And it's better, so could you go back to the framework, the workflow here?
This one.
Yeah. So here, could you tell me, this is one for repair, localizations, checking, so it's a whole framework. So
yes.
It's my suggestion that you go through all the framework instead of separate one module by module while we're losing the whole big picture.
Okay. So anyway, for this one, if the score is small, you mean it reports an inconsistency. And then for the repair part, your input is basically your original translation and all the other translations by the mutated sentences, and you try to kind of combine them and give a good translation for the original sentence.
So they do not require to retrain the model?
No, they said it's a gray box and black box. So another wordy algorithm for the repairment. Should we go through them? So
David, I think so. So my suggestion for all the follow-up presenters. So these kind of presentations, of course, it takes a lot of energies for the audience. Basically, giving the whole algorithms and introduce line by line is highly discouraged. In the future, I suggest that we go through the animation. That is also the way for you to improve the presentation skills. And giving the presentation is not only a way to share what you have read, but also a way to improve the presentation skills and how you prepare the slides. Let's go back to the previous one. So I have to stop here, interrupt. So here, still the rationale. So why this one is justified, or why this is a justified way to localize the inconsistencies?
Let me give an example. So for example, this A, B, C, D, E, F here is this sentence. And then another sentence is this. So you kind of like get the difference part, right?
So if I understand it correctly, so one is the original version, another is variant. Yes or no?
I don't understand.
So you have two sentences.
Yes.
One is the original version, original sentence. The other one is the variant. Yes or no?
Yes, I think the one is the translation result of original sentence. The other is the translation result of the variant.
So we're talking about the translation version.
Yes.
Instead of the original language.
Yes.
So in this example, what they're talking about is about a Chinese sentence.
Yes.
And if it is a translated version, how do you make the so the alignment is conducted on the Chinese sentences?
They didn't mention that.
How could they not mention that? This is a very key to understand the approach.
No, I think they just they didn't mention how they.
So in this case, are you capable of presenting the example step by step based on their algorithm?
I think sure. So for you first do the WDIF, right? So this is the first different part. And then this is the second different part. Then this one has two, because you have two different parts, you have two subsequences. The first subsequence start from here and end here. And the second subsequence start from here to here, and then skip these two and from here to here. So you have two subsequence here, two subsequence here, and then you do the cross similarity check.
Cross similarity check, and what is the measurement to evaluate their similarity?
You could do any of these four.
Blue score.
Or TF-IDF.
So this is so assume that we're using longest common subsequence, right? So assuming that they are they share the common sequence, and if for the longest common sequence, this must be a ratio, right? So the LCS over the maximum or minimum length of the sentence.
Yes.
Right, the ratio. Suppose the ratio is okay. So
for example, the ratio is for example, the subsequent we look at this subsequent against this subsequent, and the LCS is, for example, the length of this.
I got a point. So here the overall idea is that we provide different mutants, and by right, the assumption is that an arbitrary mutant or variant will not cause a large perturbations on the final translation output.
Yes.
Right.
Yes.
So in this case, they would like to check a minor perturbation, whether a minor perturbation would lead a huge change of the translation results.
Yes.
So this is idea. So this is the general rationale of the approach. So my follow-up question is that why having so sophisticated crossover similarity checking? Why not we just compare two translation outcome? We can still have the LCS, we can still calculate the measurement. And what's wrong with that?
I think what they think is that when you change some word, you will definitely have some difference in the translated result. For example, A is man and B is female. So they want to kind of eliminate the issue, the influence caused by that different mutant. So you do the subsequent, where you eliminate
have the authors justify this evaluation in contrast to the just apply LCS? So it seems to me, so as long as it is relatively high, it's okay, right? Suppose given a sentence, I change man to woman, change prince to princess, and if such a change causing a huge perturbations on outcome, we can still find inconsistency. No need to.
Maybe the threshold is here is quite
high. Or all the cases is that one alignment or one token could be very long, or for example, the sentence in one language or what a token in one language could corresponding to maybe 10 tokens in other languages. So they want to eradicate such an impact.
It's possible. So you get the common part.
Yeah, I think this idea must be justified somehow. Otherwise, we're using LCS blue scores. It seems to be sufficient to me. All right, so anyway, so we have clarified the idea. The idea is that we want to see whether a minor perturbation in input will cause a huge perturbation on output, right? Okay, let's move on.
Okay, then they have the repair repair process. And we can go to their algorithm. Yeah, sorry, it's another wordy part. So your input, your input is input sentence, translation of that sentence. And then you have mutated sentences and translation of mutated sentences, all given, for example, by Google Translator. So you put them into a large dictionary.
So it's based on the Google Translator?
Yes.
Not an arbitrary translation model?
They mentioned they have gray box and black box. So Google Translator is black box, and gray box, they use a transformer.
And since it is gray box, it means that we now send the details of the model. And
yes.
so, which means that there's an approach and techniques using the information of the model details, right?
Exactly. So they use it just like in this line too. So they rank all the elements in the T, and this rank is basically use some information in the gray box or black box, and they rank all the pair in descending order, and they use the order based on
what does this rank means? It ranks by what order?
If it's gray box, it will be the probability of translation of that
confidence order.
Or again, they didn't mention, so I think
how could they didn't mention? So given a rank, right? So they must be ranked by certain metrics.
Yes.
And if it is a black box, is that a random ranking?
Yes, if it's black box, they do the cross-reference. So let TS be the translation of your sentence and TSI be the translation of the mutated sentences. And they basically do cross-reference among each other, and rank is the average similarity.
What do you mean by the cross-reference among each other?
I think it's also similar to the previous one. They do LCS or the blue. Or
so basically it means, so when we're talking about a technique, we prefer the intuition, the big picture, instead of technical details. So if it is technical details, we can think by ourselves. As long as we have enough data and details, we can do this ourselves. Idea is that whether we can have a high level picture there for us to understand the rationale behind the technique. So is that the intuition or the big picture here that they want to compare the consistency between two translations?
Yes, I think yes.
So, but here the consistency is the metrics you're getting a pair of translation, but they are ranking by the ranking is based on the measurement of the individual translation. And how do you build a linkage between these two cases? The peer comparison to individual comparison.
Yeah, this is individual, but I guess because for black box, there are no other ways. They may be measured by some stability of your target.
And here you mean the probability of each translation. Does it mean the successful translation, or how likely it to be a successful translation, or how confident it to be a successful translation?
I didn't get the technical detail. They didn't mention.
But there's intuition and what is ranking means for the follow-up algorithm, and why the ranking is important here.
You use rank. So you use this rank when you do the for loop against all the mutated sentence, and then if any sentence first pass, you just give that as the repair.
What do you mean by the sentence first pass?
They have some criteria in the following up stage.
Do you have a big picture of the word being passed?
The word being passed.
Yes, you have a terminology of pass. So what do you mean here? And so we can talk about the big picture, right? So assuming there's an inconsistency, so so consistency means two cases: A to be wrong or B to be wrong. Suppose A and B can form a pair, right? So here the case is that if it is consistency, so if I'm the one, the first question I'm going to ask is that which one is incorrect, A or B, right? So this is the first question. Then we talk about if A is incorrect or B is incorrect, and how do we repair and modify the sentences. So if we can answer these two questions, we have a solution there.
Yes.
And in this case, in your algorithms, how do they decide when we have inconsistency? How do we decide which translation is incorrect?
I think for this S is decided by the previous steps. You see, so previously when some sentence is very different from other mutated sentence, and it's kind of like
it is also possible that one mutant is very different from the other mutants.
Yeah, that's also possible. Actually, they only find the highest similarity. So you can see here they kind of control that risk.
No, these highest similarity is to talking about a pair of the translation. We're talking about all the translations, right? Given a pair of translation, we want to see whether these two translations are consistent or not. Yes. But we're now talking about given a pair, since we now they are inconsistent. Which one in the pair is incorrect?
I don't know from my knowledge. I didn't really see that from their process.
But if we don't know which one is incorrect, how do we know on which one, or do we need a human intervention to tell the algorithm which one is incorrect?
I think for this case, actually, they try both for the original sentence and mutated sentence. For example, here, maybe I can ignore this first. This is how they repair. And then in this part, they are saying that if your input sentence is actually a mutated input, for example, your original sentence is boy something, then your mutated sentence is girl something. And if that is kind of like mutated sentence, you do some other check.
Perhaps I feel that the issue here is not finding the correct version. It's more like to make these two versions consistent. Because, for example, a lot and very good, maybe both can serve as a translation, but it's the only thing we do not accept is using different versions for different genders or different races.
Yes, you're right. But you can see the algorithms too. The input, you can see the algorithm input is a set of translation, right? So it's not about a pair of translation. It's about the multiple translations. So here, if I put in Frank, there's a lot of gray area in this presentation, so that we have to repetitively guess what authors really mean. So you can see given a sentence, right, the translation, and there's a lot of mutant translation. So which one is to be corrected?
S. It's only trying to correct the S, the translation of S.
And how do we know? So the point is that why S is the one to be corrected, right? So there must be a component, or if the author missed a component, that is also a very straightforward answer. But basically, we can say that maybe this translation is not consistent with all the rest consistency. So we try to fix the minority. That is also an explanation, right?
Yes.
So here, the algorithm here is that given a sentence, assuming that we know that it's incorrect because it is inconsistent with the others. So all the rest translation are the reference translation, right?
Yes.
And then we're talking about how do we fix it.
Yes.
Okay, maybe we can skip up about the localization. Let's move on to repair.
So you are trying to fix the translation of sentence S, and you have a set of mutated sentence that's very similar to the S. So you put them into a big dictionary and you order them based on the rank. So they have word alignment between the original sentence and the translated sentence at the AS. So that's alignment between the original sentence and translation. And then
by what technique?
Word alignment. No, they didn't mention as well.
Assuming we have a component which allow us to align the word and the translation result, right? By the way, so maybe I'm a little bit off the topic now. Yufan, is Yufan there?
Yes.
Do we have the word alignment component for our comment translation?
No, I don't think so.
Yeah, I suggested, so maybe take note here. I'm going to check whether we can find some alignment based on this technique. Okay, let's move on.
So you have the sentence and the mutated sentence, you find the replaced word. For example, this is boy and girl. Then you find the translated word for the boy in that alignment, and you find the translated word of girl in that. Oh no, sorry here. You find the translated word.
Can you write some examples down? So I think this is not very friendly. This is not friendly to almost all the audience. So would you please write some examples there? So assuming that there's a reference translation and there's a to be correct translations, and we go these examples step by step.
I'm not sure if it is convenient to use computer.
Maybe you can just using a sentence compose maybe 2 or 3 words, right? This word could be English and Chinese. So we can move on.
Wait. 1 second. How do I stop using the annotate? Wait. Oh, if we still use the boy and the girl sentence.
Okay, maybe I can write down for you. So I think this is a very, I suggested all the presenters later, we need to take the lessons for this presentation. Okay, let's move on. So give me some white space so that I can write down an example.
Okay.
So you can remember the algorithm, right?
I think yes.
Okay. Suppose the sentence that not supposed to be the boy stay in Singapore, right? Assuming all the audience know the Chinese, so the Chinese would be the boy live in Singapore, right? Assuming you know the Chinese, so the word alignment will give us the linkage will be here, 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 and here. Okay, so we have the alignment now. So would you please suggestion, how do we make the reference? Suppose we say, I'm saying that suppose there's another sentence, I will change it into the girl, right?
Yes.
The girl stay in, so is that possible that I change it to China? So we have,
no,
so example have to be in Singapore.
Yeah, because it's a
mutants. So yeah. we change one word for each time, right?
Yes.
Okay, so we just write a Chinese version. Suppose we have, so this is one to be correct, right? So maybe I change it into something incorrect. So this word 走在 means work in Singapore. So this is a different meanings about, it's a different meaning of the word. So So we still have the correspondence, right? So this is a very simple example. So the incorrect version is supposed to be here, right? So this translation is incorrect. And how do we fix this one? Okay.
Then they try to get the replaced word, meaning this inconsistency. WI.
The replaced one is we change the boy to go, and the translation happens for staying and for the translation of staying, right?
Yes, yes. Yeah. And they get the translated word. The WTI is actually the difference here, I think.
All right. So the difference is here.
And then they check if they are same type. For example, they should be numeric or all non-numeric. And then they were.
What do you mean by the type of the numeric type?
So they basically check the type of this phrase. So here is a verb. So they only have two types, numeric and non-numeric. They are both non-numeric, so they pass the check. And then you map back basically. Which one is the original sentence?
Maybe this one is already. So we know this is one to be buggy translation. So we know this is a buggy translation.
So
this was supposed to be the reference translation, right?
Yeah. Then basically the map algorithm is very simple. You just copy this 主在 to here and replace it to form the final translation.
So basically they build alliance between so here there's two examples, right? But suppose we have a number of reference, because we not just have one reference. We suppose to have a set of reference. Yes. And how do we fix this one?
Then depends on your rank. If this sentence has the highest rank, you go this first, and you find out this can pass all the check, you repair it. So you don't care all the other references in the lower ranks.
Okay, I got it. Yeah, so you can say we without any algorithm, right? So suppose you just give an examples, everything's supposed to be clarified.
Yes.
Right. So I highly suggest that in the future, once we have algorithms and especially for the PhD students, we will have a way to convert, maybe just we can look at it. Suppose with this example, definitely we will miss a lot of corner case, but this does not matter, right? Okay, Jianglian, let's move on.
How do I
can clear it for you.
Okay, so then we can skip this part.
Oh, any questions, by the way? Any question here? And Jianglian, have you prepared any questions for the audience?
Not really.
All right, let's move on then.
Yeah, there is a small example. And the rank work for both gray and black box. So that's the trans-repair. So for CAT is based on that. And they are seeing that the old models doesn't have precise control of the impact of word replacement. And the CAT is novel because it identifies word replacement with control impact, and they call it isotopic replacement. So they use neural-based language model. That's actually BERT. And they design a neural network-based algorithm, actually also BERT, to evaluate the semantic similarity between different word mutants. And then the repel and the oracle detection and repair has the same structure as the trans-repair, and it outperforms its own model.
So which means that they just replace the module, the word replacement module or the mutants modules from the trans-repair.
Yes.
Trans-repair.
Yes.
So if we just found the mutants the word replacement, and the component of word replacement has several purpose, right? So the first, they will find the mutants, and the second, they're going to align the mutants, or just for the first mutant, just for generating the mutants, and all the alignment were just using the versions in trans repair.
Yes.
Okay, so
And they compare with trans repair as their.
let me check. So the more types detects more bugs. And since the repair module is the same with trans repair, and how CAT, the cat, repairs twice more than the third bullet, how could the cat repairs twice more bugs? Or it is just because we find more bugs, so we repair more bugs, or is there any other reason?
It firstly find more bugs, and I think they are saying because you get more good mutants, so you find more.
You can look at it. So this is a work which consists of detection, the testing, testing, debugging, and repair, right? So all three activities have merged into one process. So their improvement is just on testing, which means that they can just detect more bugs than trans repair. And as for the localization, debugging, or repair, they just keep the work as trans repair.
Yes. And
right.
they have a small enhancement. For example, here they are saying 7 more types. Actually, because
it's still testing, right? So how many more bugs we can detect? It is a responsibility of the testing module.
Yes. But they are saying maybe the first mutants contribute to the detection of test.
Yeah, detection is just about testing because we found a bug. And as for how do we repair it or how do we explain it, it's just the responsibility of debugging and repair.
But you have more mutants and good mutants, and you have more candidates in later stages.
Yeah, so yeah, if you have more materials, definitely we can repair more of the cases.
Yes.
If you claim, if that is just their claim. Okay, let's move on.
So given an input sentence and word, they identify a set of words. Each of it can be like a mutant, and they should be isotopic. So firstly, they generate candidate words, and the semantic evaluation ensures the isotopic part. So I think I can escape this part because more details in later part. So you can see they first generate candidate words and they do the semantic evaluation to check the isotopic.
So the semantic evaluation is on 2 word vector instead of the input sentence.
Kind of very similar to that. You almost got the lower part. So firstly is a candidate word generation. They have a BERT model. Then for this is in, and then you want to get the candidate's replacement for the in. So you mask it, and then you feed to a pre-trained, you feed it to the BERT. And then so you get the vector. And then they put the vector into a pre-trained linear classifier to get the set of predicted words. So you use BERT to get a vector for the mask word, and then you use the linear classifier to get the output of a set word candidate. And all your candidates have probability sum up to 1, and if it's larger than 5%, then they are good, they are candidates.
So any candidates with probability larger than 5% will be a good candidate to be used for the mutants, right?
Yes.
So, and all the candidates, we apply a softmax, right?
I think yes.
Oh, softmax. So but the problem is that the BERT, the number, but we have a dictionary, which means that so the dimensionality is fixed, right?
Yes, but the interesting is that they never mentioned how they train or pre-train the linear classifier. So we maybe need to look at the code to see how they adapt with this.
Okay, let's move on. So this, anyone have a question here? If there's no question, let's move on.
Then for the isotopic part, isotopic meaning when you have a candidate word, it only subtly differs from the original word. So they say it's a novel part, but it's very similar. You just have another bird and you input that whole sentence, and for your word, you get a vector, and your cosine similarity is the similarity between your original word and
sorry, Jianglian, someone is calling me, so maybe I need to leave for a while. Just wait, give me one or 2 minutes.
Okay.
Sorry, Jianglian, I'm back. So here the semantic evaluations for evaluating the difference between sentences or the difference between tokens.
Difference between tokens, but because H is from BERT, so that also contains the sentence information, right? Context, background. And
so basically they're including the context information, right? This word is generated based on context. Okay, let's move on.
And very similar, if the similarity of any pair of words is larger than threshold, you consider is the good set of mutants. Yeah, and the oracle generation is very similar. You compare one sentence, another sentence, and their translation result. If their subsequence are having very small similarity, then you kind of report a bug.
Hi, Jianglian. I have a question here. So how they choose or define the threshold?
They didn't mention as well.
Okay.
Okay, the question is, Jianglian, if you are an author, how do you choosing the threshold? If you are an author.
I would try with sentence with issues and then just get from the experiment.
Ifan, you are asking the threshold between two sentences, right? Instead of the.
Yes, they said if the similarity is under the threshold, the cat thought it is inconsistency bug, right? So I want to know how they define the threshold.
Maybe the question is that so they will have a way to calculate the similarity. Maybe it's just more like testing the memory. So can you answer how do they calculate the similarity between the two sentences?
The similarity?
Yeah, I think the Ifan. So I think Jianglian will know the answer. Do you remember how do they calculate the sentence, the similarity or consistency? Basically, they are calculating the consistency about two translation, right? And do you still remember how do they calculate the consistency of the translation?
They use the cosine. The cosine to calculate the similarity.
No, so if it is cosine similarity, which means that each sentence will be converted into a vector, right?
Yes.
So here you can look at the second bullet. Jianglian saying that they are comparing the subsequences of the translation. So, and how does the subsequences will be linked to the vectors? Maybe Yufan, did you remember how do we calculate the consistency between two translations? Yufan is still here?
So they input the whole token sentence to the BERT and use this to embedding it into the word vectors.
I think
Right.
that might be a way to do this, but based on the authors, they are just, do you still remember they have a way to remove one token and do the translation. So they have a set, each sentence will have a set of subsequences. And for each subsequences, you will have a translation. And they will calculate the translation. They will calculate the translation pair of each subsequences to have the largest, have their maximum similarity. Maybe Jianglian, you can just go back to show the process. Yes, yeah.
Yeah.
I think this is where it is. So there's no burn model here. So giving to translation, they will just remove some specific slides to have the subsequences, and they will calculate the similarity of each pair of the subsequences to have the similarity score. Have I myself not clear? Have myself understood?
Yes.
All right.
Thank
Okay,
you.
anyways, it's good to raise the questions. Anyone have the questions until here? I think up until now, Jianglian has clarified the majority of the confusion.
Okay. Then the process is also the same for the repair. They use different ways to do the rank, and then you repair it based on the rank. And for the original sentence, you generate mutants and get their translation and do the rank, and you map back the difference. If mapping back fails, it will select the translation with a lower ranking.
And how do you design the failure?
If I remember, they have grammar check. That's very intuitive check.
So you think about it on the fly, or it is taken from the paper?
I think I took from the paper. They basically have grammar check on every step. Yeah.
I see.
And then when you are fixing your input sentence, the mutant, then you use the same repair process as the original sentence, but you mark the output as a candidate solution. Then when you check if the candidate solution is good, you test with
Sorry, so here the question is, what for the original sentence and what for the mutant?
What for the original sentence?
So is that means if we want to fix the original sentence, we will have 4 steps. If we want to fix the mutant, we will have 2 steps or something else.
You have extra 2 steps.
Okay, so my guess is correct, right? So here is the steps to fix the original sentence or fix the mutants.
Yes.
And the question that why fixing the mutants will be different from the steps for the original sentence.
I think so. This is the extra step for the mutant. They again.
So this is also coming from the paper 2 years ago.
Yes. Okay.
So it's a little bit tricky, right? So their real contributions comes from a BERT-based isotopic generation, isotopic replacement generation, and that is all. And all the steps are coming from the old paper.
Yeah, and they are saying the new one is much better than the old one, but.
Okay, so maybe we'll come back to the previous question, and why the steps for the mutants, why the steps for fixing the mutants will have 2 steps more than the set for the original sentence.
Yeah, again, they didn't mention, but I think they are feeling that for mutant sentences, it's more unstable. So you need to compare with the the fixed result of the original sentence. So you need to refer back to the fixed result of the original sentence. So it's more reliable.
What do you mean by fixed? The original one is supposed to be the reference one, right?
The original sentence maybe goes through the same process as this to get fixed.
I just feel a bit weird. And also I fully depends on the report of Jianglian. So from my point of view, once we have decided the consistency, the inconsistent translation with the others, it does not then matter whether a sentence or whether a translation is from the original sentence or from the mutant sentence. Right, because they're supposed to be symmetric.
But at least mutated sentence is generated by us, and original sentence is a real sentence.
So which means the confidence of translation for the original sentence is higher.
I feel so.
And if it is higher, and how does the step to address the issue of less confidence?
At least the original sentence also went through the same repair process.
What do you mean by the original sentence went through the repair? So if a sentence goes through the repair stage, which means that this sentence the translation of the sentence is incorrect.
You could say it's not consistent, but after you repair it, it will be more consistent. Then you refer back to the more consistent version of the original sentence.
Then the question goes to Zhang Yi. Okay, Zhang, okay, you can move on. Zhang Yi can. So here the question is how many sentences? So suppose we have several translation, right? And there's supposed to be one buggy translation or multiple buggy translations.
From their stats, there are many translation problems. And
okay, let's move on. So here, maybe I have the other suggestion, but overall approach framework is very clear now, right? Okay, let's move on.
If we go to the experiment setup, they used two translators, the transformer and the Google Translate. And the data set is from the NUS data set. And do you want me to go through their result? How?
I don't care about result, I care about the experimental design.
That's all from the paper. All the remaining pages are for the result.
And how do they check the fix is correct, right?
Manual check.
And manually check. So if it's manual check, there are so many candidates. There's thousands, tens of thousands of candidates. They manually check all of them.
For example, mutant correctness, they do manually check and get this number. And for bug detection, they also have manual check. Manual evaluation for the bug detection with these numbers. And for bug repair, they also have manual inspection of whether the cat improved the result or not, or manual.
And how do they select the personnel?
They once mentioned random.
So here the suggestion is that when we're giving the presentations, of course, we look into the problem, we look into the approach and the solutions. And as for the researchers, we also care a lot about evaluation and how given the problems, and you can see the problem, given the framework, right? There are several stages: the testing, debugging, localizations, and repair. And for each stage, we might conduct and perform stepwise evaluations and have an end-to-end evaluations. And how do we design those experiments? That is also something we need to take from the other publications.
For the automatic evaluation, we just compare cat with the trans repair and seeing outperforms. And for the correctness of them, they really did manual check for almost all questions.
Mm. All right, anyone have any questions here? Okay, if it is not, so there's okay, you can just report some case study, right? This is a qualitative study.
Yes, actually, I feel it's not informative enough because they only give the original bad translation and the report, but they didn't mention what mutants they used and the detailed step-by-step breakdown. But this is a case study. And for example, they have numeric values that's mistranslated. And then
that is problematic. So I think the mutants and the translation of the mutants really matters.
But they didn't mention. Yeah.
Okay. Up until now, so it's almost the end of the presentation, right?
Yes, that's all. They also, for the manual validation, they also review the process. That's all.
Okay, so my first question. So here I suggest I know it is quite silent here. So may I suggest any of you ask 1 or 2 questions to Jianglian in this presentation? Maybe Mengyue, do you have any questions, or can you raise 1 or 2 questions to Jianglian on this presentation?
Actually not. I think she has. Can you hear me?
Yeah, we can hear you.
Yeah, I think she has already gave the details and explain
so maybe,
all the things.
Maybe I give you 2 minutes to think about a question and raise it to Jianglian.
Okay, maybe later.
Okay. Hello, Yufan.
Hello.
Can you raise 1 question to Jianglian about this presentation?
I think maybe you can talk about the baseline. The baseline is trans repair, is it?
Yes.
Now the new framework is CAT.
Yes.
Yeah. So how they compare the two? They all manually compare these two, or have some framework to compare?
For all questions, they just, I think they have script to give, or for example, the mutants number or the bug number given, and they had for that part, they just use that number to compare, and they also did manual comparison for both, for some of these questions.
Okay.
This is manual inspection. Yeah.
Maybe I raise a question. Yeah, Dr. Xiaoyan, please. Maybe you can raise 2 questions.
Yeah. May I ask whether the trans repair also use the manual, labeling or such kind of methods to evaluate trans repair, right?
Yeah, then in the trans repair paper, I think they also use very similar manual evaluation. I didn't put in this.
It seems to be a quick paper to me. So basically they keep the same framework, but change the capability or improve the capability of 1 component.
Yeah,
right.
This is also Mahana. Could you please? I think I get the point, but could you please conclude the improvement from CAT? High level, not.
You mean the trans repair?
From the improvement from CAT to trans repair, high level.
You mean from the trans repair to CAT?
Yeah.
You mean CAT is a new one?
Yes.
Me or Jianglian?
Jianglian.
Okay.
The effectiveness, there are 4 parts: the effectiveness of generating mutants, and the effectiveness of bug detection, and also bug repair, and lastly, the efficiency, meaning the time cost. How they give numbers, basically, for example, the mutants, they are saying the number of mutants per sentence for cat is like very high, but for trans repair is very low. Yeah, the number of mutants for different types for cat is very high, higher than the transformer, etc.
So they use, I remember you mentioned they use the neural, I mean the neural network, namely BERT, to improve the quality of the
yes,
the detection rate. Yeah.
Yeah.
So I mean, in very high level, so this is the only component they improved from the technical part. I mean, from the method level.
Yes.
Did they mention? I remember you explained. Could you please explain again why they can? I mean, generate such conclusions that because of use BERT, then it could be improved.
Because for example, the word candidate, this is the yin is your target, and you want to get similar words. And when you do the H, because BERT considers influence from all words in that sentences so your H also contains like all the words in this sentence. So you have more context.
Yeah, my take is that they improved the what to vector into the context-based what to vector, so that they may generate more natural or more relevant replacement. So that is just my take.
I think so. So I think this paper can be accepted. Maybe their writing is quite good.
Oh, definitely. There's Mark Harmon there. He is quite good. His writing is excellent in the community.
Yeah.
But I think Zhang Jie is corresponding author, but she must be responsible for the majority of the writing, and she is also very good.
Okay, because for me, if it is quite a very simple improvement, right?
Yeah, so if you look at the paper in details, it might be. But anyways, they convince the reviewer.
Yeah, so that's why
that is their strength. I think it is not very easy for all the authors to play that trick.
Yeah, I just have I just have such feeling. That's why I asked Jianglian
to re-summarize it.
Yeah. Just in case I misunderstood something. Yeah.
And yeah, Mengyue, have you think about the question? It has been 1 minute, 2 minutes.
Yeah, I think at first I think you may want me to give some questions about the presentation, right?
So what do you mean by takes for example?
You mean what kind of question should I give to Jianglian?
So whatever question, it is fine.
Oh, at first I thought you may want to give some suggestions to the presentation. So I think she gave the best. But if the question is about this paper, I think the way they solve this or improve the cat is much more simple. Yeah, very simple way.
Yeah, this is good comments. This is comments. So yeah, so I raise a question because how to raise questions and how to think actively about the presentation is also very important. So maybe I also try to ask some other one. So maybe given a time limit, so I encourage the audience here try to think about 2 or 3 questions to Jianglian to think about it. And usually when you are go to conference and you listen to the talk, listen to their presentation, raise questions in a kind of way is a very good way to interact with the presenters, show interest, start the conversations and build a relationship, build a friendship. So I'm not sure how many of you were still in Singapore when FSC held this year, but my suggestion is that when you go to the conference, when you look at the presentations, you should not be shy and you raise your hands and ask questions. Since I think most of us are nobody's or only in the beginning stage of establish yourself in the community. So even if you raise simple questions, so that is also a very good chance. Anyone
Thank
try
you.
to raise some questions to Jianglian? Yifan, do you have any questions?
I have no questions.
No questions. Okay. Nimisha, David, do you have any questions?
Not from my end.
Okay, so anyone else? Okay, if there are no questions, maybe call it a day. And as for Yufan, so there's one question to you, and maybe you don't know how to answer here. So whether the cat-based approach can be used for addressing the out of vocabulary problem. Hello, Yufan, still there?
Yeah, I'm also thinking about that.
Yeah, they have a way, so they will have a context, and they have a BERT model to synthesize a new word. And whether this approach will be available, you can just start with the gut feelings, but you can provide a more logical justifications later.
Okay.
Okay, so maybe we can call it a day then. Thanks for Jinglian's preparations and thanks for everyone's attendance.